Welcome to How to Implement Compliance Controls for Sensitive Data. This module explores the practice of setting compliance controls on data that is stored within the SQL Server database. We will also review the advanced threat protection options within the Azure environment. In this module, we will talk about how and why data should be classified. We'll also get into more security topics like how to implement row-level security and dynamic data masking, along with how to use Microsoft Defender for SQL and the Azure SQL Database Ledger. Data classification defines how data must be treated, whether public, confidential, or highly confidential, and supports the creation of governance policies that align with regulatory requirements like HIPAA and GDPR. Classification is done on a column-by-column basis, allowing mixed sensitivity levels within a single table. This metadata, initially stored via extended properties in SQL Server Management Studio, is now maintained in the sys.sensitivity classifications catalog. You can view that in SQL 2019 and later, and you can also use it inside of the Azure SQL Database. So by assigning appropriate permissions based on classification, organizations can ensure users only access data that they're authorized to see. The benefits include enhanced data protection, improved compliance, and clearer visibility into data sensitivity, making it especially valuable for a lot of industries out there, finance, healthcare, government, and more, to help secure data governance in their environments. How your data should be classified outlines the practical steps for implementing data classification within SQL Server and Azure SQL Database. Remember that data is classified on a column-by-column basis, allowing for granular control where a single table can contain a mix of public, general, confidential, and highly confidential information. Azure SQL Database can automatically suggest classifications based on column names. That will help streamline the process, while administrators can also go in and manually apply classifications using SQL Server Management Studio or T-SQL commands like add sensitivity classification. You can also just do it right inside the Azure portal. The SMS interface shown on the slide demonstrates how you can assign schema, table, column, information type, and sensitivity label, such as marking a birth date column as confidential for GDPR. This approach enhances data security, supports regulatory compliance, and again, standards like HIPAA and GDPR, and it helps improve data governance by making sensitivity levels explicit and enforceable. Organizations will benefit from this clear, structured data sensitivity labeling. Let's see how auditing in Azure SQL Database helps track and log database events for security, compliance, and operational insights. Auditing can be configured at both the server level and the database level, with logs written to destinations like Azure Storage, Log Analytics, or Event Hubs. However, it is recommended to enable only server-level auditing and leave the database-level auditing disabled unless specific needs arise, such as using a different storage account, a retention period, or a different event category for that particular database. Server-level policies automatically apply to all current and future databases under that server, ensuring consistent coverage and simplifying management. This setup supports regulatory compliance and helps analyze activity patterns, and also enables the detection of security violations. By following best practices and leveraging server-level auditing, organizations can maintain a strong security posture while reducing administrative complexity. Let's look at some key components of the default auditing policy here in our SQL database, focusing on 3 essential action groups that help maintain security and compliance. The batch completed group audits all queries and stored procedures that are executed against the database, providing full visibility into the user and application activity. The successful database authentication group tracks when a principal successfully logs into the database, helping administrators to monitor legitimate access. Meanwhile, the failed database authentication group logs unsuccessful login attempts, which is critical for detecting potential security threats or unauthorized access attempts. These action groups form the foundation of a robust auditing strategy, enabling organizations to analyze activity patterns, identify anomalies, and meet regulatory requirements. For example, it can be used to monitor transaction activity, ensure patient data access is secure, and even track authentication events to prevent breaches. Integrate data classification with auditing to enhance visibility into access to sensitive information within SQL databases by logging the sensitivity label of the data returned by queries such as confidential GDPR or highly confidential auditing provides a powerful way to track access to classified columns. The audit log captures metadata like sensitivity rank, label ID, and information type, things like the social security number or a name, allowing administrators to monitor who accessed what type of data and when. This capability is essential for maintaining regulatory compliance, detecting unauthorized access, and analyzing activity patterns that may indicate security violations. So by combining auditing with sensitivity metadata, organizations can gain a comprehensive and actionable view of data across their SQL environments. SQL Server uses dynamic data masking, or DDM, to protect sensitive data by obscuring it from unauthorized users at query time. DDM allows administrators to define masking rules on specific columns, such as maybe the phone number, email address, and more, so that users without appropriate permissions see masked values instead of the actual data. For example, the phone number column is partially masked here to show only the last 4 digits, while the email address column is fully masked using a built-in email function. This slide demonstrates how a user, the DDM demo user, can query data and sees the results, ensuring privacy without altering the underlying data. Importantly, server administrators always retain access to the unmasked data, and masking can be lifted by granting specific rights to users. Users need the select and unmask permission to see behind the mask. Benefits of DDM include simplified data protection, reduced risk of data exposure, and easier compliance with privacy regulations like GDPR and HIPAA. It's especially useful in scenarios where developers, analysts, or support teams need access to production data but should not see sensitive information. Here we see the 5 built-in masking functions available in SQL Server to protect sensitive data from obscuring it from unauthorized users. These include the default mask, which fully hides data based on its type. This is ideal for general purpose protection. The credit card mask, which reveals only the last 4 digits, helps secure payment information. The social security number mask, which displays data in the format of, obscuring all the numbers except the last 4, ensure privacy for personal identified information. And the random number mask generates values within a defined range to obscure numeric data while maintaining the format, and custom task mask, which allows us to see the first and last character of a string with a placeholder text in between. This is useful for partially revealing names or IDs. These masking options allow organizations to tailor data protection based on context and sensitivity. It supports compliance with privacy regulations, and it enables safe access for developers, analysts, and support teams without exposing them to real data. Some use cases here can include masking data from an application from the user who have no direct access to the database, or restricting private information for a group of users, or providing masked data to external vendors, where you need to protect sensitive data while still preserving the relationship among the items in the data, or even export a copy of your production database to maybe a lower environment for development purposes with a user who doesn't have unmasked permissions. The export of the data will need to be in that masked format. Row-level security enforces fine-grained access control by restricting data visibility within a table based on user attributes. This is achieved through two types of predicates. We have a filter predicate, which limits access to rows that meet specific conditions during select, update, delete, and insert operations. And we also have a block predicate, which prevents unauthorized data changes during insert, update, and delete actions. These predicates function like dynamic where clauses, ensuring users only interact with data they're permitted to see or modify. To strengthen this security model, Microsoft provides advanced threat protection for the Azure SQL Database, which monitors connections and query activity for suspicious behavior. For full effectiveness, it is recommended to enable auditing, which logs database events and supports investigations when anomalies are detected. Together, row-level security, auditing, and advanced threat protection offer a layered defense strategy where protecting sensitive data and detecting unauthorized access are critical for compliance and operational integrity. Here we see practical application and implementation guidelines for using row-level security in SQL Server to enforce fine-grained access control in targeted scenarios, and implementation tips for allowing row-level security in SQL Server. On the one side, we see it highlights how it's useful for isolating departmental access, ensuring each team views only its relevant data, enhancing internal privacy. In a multi-tenant environment, it restricts customers to their own company's data, preventing cross-access and protecting client confidentiality. For compliance, it limits access to regulated data based on users' roles, supporting standards like GDPR. On the best side of the slide here, we are going to see that it recommends organizing predicate functions and policies in a separate schema for clarity, avoiding type conversions to improve performance, and minimizing joins and recursive joins here to maintain efficient query execution. Microsoft Defender for SQL offers layered security features for Azure SQL Database and Azure SQL Managed Instance. It emphasizes the importance of proactive monitoring and compliance. Microsoft Defender provides a suite of protections, including Advanced Threat Protection, ATP, and continuous monitoring for suspicious activities, SQL injection attempts, and anomalous attacks or query patterns. To fully leverage ATP, it's recommended to enable auditing on your databases. This ensures that any detected anomalies can be thoroughly investigated using detailed event logs. Additionally, the SQL Vulnerability Assessment scans databases against a knowledge base of security roles, flagging non-compliant configurations and helping maintain best practices. Together, these features offer a robust defense strategy that supports regulatory compliance, enhances threat detection, and improves incident response. Azure SQL Database Ledger feature enhances data integrity, auditability, and trust within our Azure SQL Database environment. This feature provides tamper evidence capabilities, allowing your organization to cryptographically prove to auditors and business partners that the data has not been altered. It simplifies auditing by offering verifiable records that support compliance and security controls, backup standards, disaster recovery protocols, and more. The ledger also fosters increased trust in multi-party business processes by eliminating the need for complex network consensus mechanisms, ensuring consistent and reliable data management. Additionally, it guarantees data integrity, even in off-chain blockchain scenarios, by protecting against unauthorized changes, including those from malicious insiders or administrators, without compromising performance. Azure SQL Database Ledger ensures data integrity by providing transparent protection against tampering, even from attackers or privileged users like database or cloud administrators. Through robust security measures and continuous monitoring, it significantly can reduce the risk of data breaches by maintaining trust in the authenticity of your stored data. These capabilities make Azure SQL Database Ledger ideal for scenarios where data authenticity and regulatory compliance are critical. Here we see how to enable and configure Azure SQL Database Ledger to ensure tamper evidence across all future tables in an Azure SQL database. By selecting the checkbox Enable All Future Tables in this database, every new table will automatically be created as an updatable ledger table, even without explicitly specifying ledger equals on in the create table statement. This guarantees that all data changes are cryptographically tracked, providing clear evidence of tampering and enhancing data integrity. Additionally, enabling automatic digest storage selected by default creates a secure Azure storage account and container to store cryptographic digests, which are used to verify the authenticity of data over time. This setup supports audit readiness. Microsoft Purview introduces a unified data governance solution designed to manage and govern data across on-premises, multi-cloud, and SaaS environments. It's available in many Azure and M365 services. Microsoft Purview enables organizations to create a holistic, up-to-date map of your data across your data estate through automated data discovery, sensitive data classification, and end-to-end lineage tracking. It simplifies data access by allowing users to search using familiar business and technical terms, and provides insights to refine glossary terms, improving search relevance. Users can also visualize their entire data domain by asset dimensions such as source type, classification, file size, and more. Purview automates scanning and classification, integrates our metadata into the centralized view, and it supports secure access management. This empowers data curators to enforce governance policies and enables data customers to confidently discover and use trustworthy data, making it really ideal for enterprises seeking to enhance compliance, transparency, and operational efficiency across their complex data landscape. Here we see how Microsoft Purview's Unified Data Governance Service enables organizations to manage and secure data across on-prem, cloud, and also SaaS environments. At the core of Purview are three key components: the data map, which automates metadata management and builds a graph of all your data assets and their relationships. You also have the data catalog, which helps users discover trusted data sources using familiar business terms and classifications. And you have your data estate insights, which provides visibility into the types, sources, and distribution of data across your organization. Purview integrates seamlessly with services like Azure Synapse, SQL Server, Power BI, Azure SQL, and Microsoft 365, creating a holistic, up-to-date view of your data landscape. Through automated scanning and classification, Purview empowers data curators to manage governance policies and enables data consumers to find and use trustworthy data, supporting compliance, improving data accessibility, and enhancing our decision-making across the enterprise. Here is a screenshot from the Microsoft Purview Sources interface, showcasing how data assets are organized and managed across global regions. Collections such as Americas, APAC, and Europe are visually grouped, each containing registered data sources like the highlighted Azure SQL Database N6S instance. The interface allows users to filter, register, and view data sources using tools like map view, table view, and keyword search. This structure supports Microsoft's Purview's broader goal of unified data governance, enabling organizations to automate data discovery, classify sensitive data, and map data lineage across on-prem, multi-cloud, and SaaS environments. By organizing sources into regional collections and linking them to specific assets, Purview empowers data curators to manage access and security while helping data consumers locate trustworthy, well-classified data efficiently. Now let's look at how to use Microsoft Defender for Cloud to identify and manage security risks in Azure SQL environments. It shows issues flagged here by advanced threat protection, such as suspicious activity or potential vulnerabilities, can be reviewed under the security section of the Azure portal. To perform a vulnerability assessment, scanning results must be stored in an Azure storage account, enabling detailed analysis. The screenshot here highlights the AdventureWorks database and shows that Microsoft Defender for SQL is enabled at the subscription level, which with this access to tabs for recommendations, security alerts, and findings. This setup allows administrators to proactively monitor and respond to threats, ensuring compliance and strengthening the security posture of their SQL databases. Now it's time for a knowledge check. Question 1. Where is the data from data classification stored in SQL Server 2019? Answer: in the sys.sensitivity classifications catalog view. Question 2. Which is not an option to store a vulnerability assessment data? Answer: physical disk. Question 3. Which of the following features automate data discovery through the provision of data scanning and classification as a service? Answer: Azure Purview. Now let's look at how to enable Microsoft Defender for SQL and data classification. Now we're going to move on into Lab 5, where we're going to talk about how to enable Microsoft Defender for SQL and data classification. So that is where we're at. That lab finds us here inside of Azure and again inside of Azure SQL. And from here, we're going to look at our vulnerability assessment, and we're going to take a look at the Microsoft Defender for SQL. And a lot of this is going to be available for the server. So I'm going to use one of the servers that we used before, that is our Lab 1 server there, the DP-300 Lab 1 here. And we can get into that Lab 1. What I'm going to do is I'm going to go off to the side here. I'm going to scroll down a little bit, and I'm going to choose the option right here called Features. And right here is where I can enable Microsoft Defender for SQL. So we've brought Microsoft Defender into SQL, and it can do a lot of things for us. Now what we have is we have to go in. I'm going to show you that it gives us recommendations that we can view. And after it's been enabled, so there's one option here that I can work with here, and we could have it go in and show us our security incidents and alerts that it has found. We can also have it scan for vulnerability assessments here. And so I'm going to have it view all recommendations in Defender in the cloud, and it's going to take it a moment to kind of go through and look at some of the recommendations that it has. So we'll give it just a moment to find itself there. Note too that you can go in and download this as a CSV report. You can open up the query to see how it's extracting the information, make modifications. There's a governance report, and we'll give it just a little bit more here to wait on that. And then there's some guidelines and feedback, and you can go into the classic view. Now I want you to note that it's going across many environments, not all of them in Microsoft. And you can see that it has recommendations by risk. So it's going to organize it by high, medium, and low risk. And then you can kind of see a cycle that it's going through. So it's going to show us down here. You can see some of the risks that it has found for us. And so I have it's for Fabric also, but it also has it here for our SQL database. And a lot of these are fairly low. Some recommendations that it has, and I can scroll through it, and it tells me the privileged roles should not have permanent access at that resource group level. So I can click on that, and I can get a little bit more in depth there. Now it's going to give me a little bit about the risk that it found, and it's going to also show me some techniques I can use. I can get initial access. I can read a bit more about that process. I can also go in and see the action that I should take, and then the recommendations for setting that up. And then I can see the current role assignments, but I can also get in here and take action on this. So I can find it very helpful here as it goes item by item, making recommendation by recommendation. And it's telling me a little bit about some of the things that it can do. So here's the server machine, SQL Server on machines, where it finds a vulnerability that needs to be resolved. So I could click on that, and I can see again, it's telling me my risk level. The resources assigned, also some actions that I can take if I want to work with that. The action from some of the recommendations, and then the database that it's affecting. So a lot of detail here. You can see that it has 16 out of 58 issues here. And there's a graph here that I can look at, and there's some of this that I may want to go in to make certain that I can make my adjustments. And so it says it's unhealthy. Here's the query that I can run to help it, and you can see infected resources. So it's actually pretty thorough, and I may want to go through this and see other things that it offers. Once it's enabled, you get it for 30 days. So you can see a little bit more here. I can use it to help me make some decisions. There's actually a lot of good stuff in there. There's a section where we can see alerts, and you can create alerts from here. There's some sample alerts that I can create right here, and it will do it for me. Using some resources, I can create sample alerts here. So not just SQL, but it goes beyond that into Azure. And this is currently in previous here that I can go back out of this and take a look at some more information here. Sample alerts, which we did. I'm going to close out this part here because it's filtering. Where we have the DP-300, and we actually created alerts. There's a lot of them here that have been created. So it has about 110 alerts. And then we can come here and we can see that it really helps us to keep track of some of the very important issues. As we look through this list, like suspected prompt injection. Also here, resources, we can look at SQL injection issues. And it's trying to give me a little bit more about some of these sample prompts. And I can get different activities that we're looking at here and click on them and get a little bit more information about what may have occurred. and I can copy it into JSON, and it's a sample alert that I can set up, and any one of these would be very helpful. You can also take action that will take you into another window where it will help you with remediation. So these are sample alerts that we can get into, and we can also really put some of the heavy guardrails on our system to be alerted here when things are going on under the covers. Now this also is to be alerted. We can actually have a security alerts map. That will give us another look here if we want to take a look at that. It will show us where in the world we might be getting threats from. It's not detecting any threats right now, so it's a pretty good option here that we can use to see where threats are coming from. The security alerts here, there's other things that we can look at, but those are some of the really good options. So the recommendations, the security alerts, you can set those up. And then also the vulnerability assessment, where you can run this and see where you are the most vulnerable right now. So I love the recommendations and the ability to set these alerts up for us. Some common things that occur in the SQL environment, you can have alerts created for you. But we have some other options that are available to us too, and these other options are available in the database. So I'm going to go back to our DP-300 lab. Actually, I have to go a little further back. I'm going to go into the database. So we have a number of databases, as you know, that are riding on DP-300 Lab 1. So a number of them, and we get into one of them here, and I'm going to use this one. It's our AdventureWorks LT. And what we can do to the database is really a lot of things. You can set up data encryption. You can go in and do the Microsoft Defender for the Cloud here at the database layer. So there's another layer that we can look at. So in particular for the database, we can view recommendations and work with alerts. And then we have also the ability to do classifications. So what we have is we have our database that has a schema here, and there's a bunch of recommendations that it has for the databases. I found about 14 recommendations. So it's taking a look at each of those. I can see the fields, the names, the sensitivity labels that might need to be added here. So what we can do is we can accept all of these recommendations and add them in. We can label our fields with sensitivity labels like it recommends here. But we can also go in and we could add our own classifications. So I can come in here, I can go into sales or DBO schema. I can find my table and then the field that I would like to work with. And then there's a field here called email address, and I could classify that as contact information among other things. And you can see there's a whole bunch of options in here, but I will set that up as contact info, and then I could maybe mark it as confidential. And you can see the other options in here too. So you can add your own classifications, and you can use classifications from it. It gives you a lot of options, as you can tell. I could also go with the classifications right here. I could save it, and then I could add in more classifications if I'd like. But I would also like to go in and do dynamic data masking. So maybe what I want to do here is look at the masks that are already here. You can mask. It's telling you which fields it recommends for you adding masks to, and I can go with the ones that I have here if I'd like. And we could go with those. Or what we could do is we could go in and add our own masks. And now this is to be done through, this can be done through T-SQL by going into the field, but you can also do it right here. And we can see it can easily be done by picking up your schema, your table, the field in that table that you would like to add the mask to. And it's based on nvarchar, the data type here for that field. And you have different options based on that. So you can choose the default credit card, email, the string text here, which is more custom. And then you can also choose other options, but it's all based on that data type. So I'm going to go ahead and add the email one. And once we set that in, this could be a really good option that we're going to want to save this so that we can use it. So I'm going to click on the Add button there. And what we're going to do is we're going to save this. So we have to save it right there. So we've added that function. We've added the mask. So the email address, if you want to be able to view it, you're going to have unmask and select against that field. So we'll test that out. And I'm going to go into, let's see, I'm going to go into our Management Studio here. And in the Management Studio, I already have gotten this ready. I got connected. And I did connect to the database. And what I did is I logged in as our DP-300 admin there. And I put my password in. And once I logged in, I can get into it. And right here, I can run this statement. And when I execute it, I can see everything, including what's in that email field. So the admin is not subject to the data masking. However, others are. So by default, I have select and unmask against the email address field. But if I go in and we add, let's say, a user now, right now in AdventureX, I have a number of users that will take a look at those. I have it. Let me refresh this. I have a username Bob. I also have a new username Tim and a couple of other people that are in there by default. But I'd like to make a new user called Jan on that database. And then I want to refresh this, see that Jan is there, make certain that I've added her. And then I'm going to give Jan the ability to work with and be a member of that database, DB Reader and DB Writer. So I'll add that in. And I don't know if we can really see those roles. We might have to refresh it a little bit, but gave her some permissions there, the DB Reader and DB Writer. And so if I double click on those, I may actually, no, I can't see it anymore. Okay, we have a script and we're going to see it, but we should add in the writer here and then we can double click that. And now we're going to run the script. And then doing so, I'm going to go ahead and execute the command here. Execute as user Jan now. And so I'm logged on as the DB admin, but I'm going to go ahead and run this. I'm sorry, the DP-300 admin. I'm going to run this as Jan. And I want to test it out as Jan. So I have that execute as user that you can see right there. So let me set that up. And it looks like now when I try to query, I get the mask. So I don't see the entire email because I was logged on as Jan. And Jan doesn't have the ability, doesn't have the unmask permission. So we're going to use that we've executed as Jan and we see that we have been blocked. And so we can't see it. So now we're going to go ahead and execute unmask to Jan. And now you can see she sees it. So you have to have select and you have to have unmask in order to view behind it. But you can also revoke her unmasked permission or deny her unmasked permission. We have the capability of doing that. And notice when I revoke her unmasked, she can't see it now. So at any point I can grant and deny or revoke. Revoke just means I'm going to take back her permission. So the masking should be very helpful. So a lot of ways to work with this, as you can see. Hopefully these are fun ways that you can test some things out here and have a lot of options. Creating the mask through the portal or creating it through T-SQL. There's a lot of ways to do it. And notice here we can go back and see the classification. We had the phone number. We looked at Defender. So we looked at classification, dynamic data masking. We could also turn on an audit. And we also have a built-in ledger. And we'll talk about these coming up in our lecture. There's also data encryption here. Notice that it's on by default. Notice I can turn on very easily, always encrypt. A lot of this can be set through T-SQL also, as you know, in our Management Studio is one option. So a lot of ways that we can lock down not only the server, but also our databases. Hope you enjoyed this section and hope you were able to follow along and that you enjoyed the lab, and see you in the next section. Thank you for your time. Please take a look here at some of the references we've provided. In this learning path, we explored how to configure authentication and authorization in Azure SQL Database and in SQL Server, including key, principals, and role-based access. We also learned how to safeguard both data in transit and at rest using transparent data encryption, always encrypted, dynamic data masking, and firewall configurations. Finally, we dove into implementing compliance controls for sensitive data, leveraging tools like data classification, advanced threat detection, Azure SQL Database Ledger, and Microsoft Purview to ensure integrity, traceability, and governance across your data estate. Thank you for your time and attention in this optimization section. I look forward to seeing you in the next.